everybody, this is Shivakumar. Today we are going to discuss about the optics. So what is optics? Optics is nothing but the study of light. The study of light is called optics. Okay, study of light. Study of light is called optics, right? So optics is divided into two forms. So the first one is geometrical optics and next one is wave optics. So this optics is divided into two types. The first one is geometrical optics. Geometrical optics. And next one is what I said, that wave optics. Wave optics, right? So in geometrical optics we are going to study about the reflection, refraction, like that. Reflection, refraction, refraction. And in wave optics we are going to discuss about the interference, diffraction, polarization. So we are going to discuss in the wave optics. So interference, diffraction and polarization we are going to discuss in wave optics, and in geometrical optics we are going to discuss about the reflection of light, refraction of light. In that also the reflection of light in plane surface and curved surface, and refraction of light in plane surface and curved surfaces we are going to discuss. Okay, so why here we are having the two types of the optics? Why? Because the light ray travels in the form of rectilinear propagation, right? So the light ray travels in rectilinear propagation. Rectilinear propagation. What? Propagation. So the light ray is always travels rectilinearly. Rectilinearly means what? It is a straight line. It won't bend in a homogeneous medium, right? So here the rectilinear propagation is going to be taken place for the light ray. Okay. So here, when a light ray travels in a rectilinear motion, we are going to use the geometrical optics. And if the light ray is moves in the form of waves, then we are going to use the wave optics, right? So light is having the dual nature, right? Light is having the dual nature. First one is particle nature, and next one is the wave nature, right? So light is like this light, right? So light is having the particle nature, and this light is having the wave nature. Okay. When we are going to use wave optics and when should we have to use the geometrical optics? So let us take a ray is coming. Okay, so it is coming in a rectilinear propagation, right? So then what happens when the light ray is coming? Then it get some obstacles. Okay, so then what happens? Then the light may have to be bent, right? So then what happens? If the wavelength of light is less than the obstacle, then we are going to use the wave optics. And if the length of the obstacle is more than the wavelength, then we are going to use the geometrical optics. So now we are going to discuss about the geometrical optics. So in that we are going to discuss about the reflection, refraction of the plane surfaces and curved surfaces. Okay, so the first one, so geometrical optics. So whenever we are going to start, then first we have to know some basic definitions of the terms which we are going to use in this chapter. So the first one is ray. What is ray? So what do you know about the ray? So ray is the straight line path taken by a light in a homogeneous medium, right? It is a straight line path. Taken in homogeneous medium, right? So what is homogeneous medium? Homogeneous medium means the refractive index to be equal. That means let us take the homogeneous medium means the same medium to be there. So let us take the water. Water is having the same at the one place, and air is one medium, and glass is also one medium, right? So these all are called mediums. So let us consider when a light ray is coming inside the water, then the whole water is homogeneous medium. So when a light ray is coming in air, that means the whole air is one medium. We can call that is homogeneous medium. Next we'll see beam. Beam. What is beam? So beam is the bunch of rays. Beam is bunch of rays. Bunch of rays. What is bunch of rays? So the bunch of rays is that the rays coming more. So the bunch of rays is called beam. So we are going to have the three types of beams. So three types of beams we are going to have. There are, first one is converging beam, second one is diverging beam, and third one is parallel beams. So the first one is converging beam. Converging beam. What is converging beam? The rays, the beams are converging at a particular point. The rays are coming to a particular point. So then we can call that is the converging beam. Next we'll see diverging beam. Diverging beam. What is diverging beam? The rays which are move away from a point. That means let us take this direction. So here what happens? The rays are diverging. They are moving away from this particular point. So we can say that is diverging beam. Okay. Next, parallel beam. Parallel beam. What is parallel beam? So we know that the parallel means the lines will move parallel to each other. That means the rays are moving parallel to each other. Right? The length between these two will be equals to the length between these two. Right? So these are parallel beams. Okay. Now coming to another point, reflection. So what do you know about the reflection? Okay. What do you know about the reflection? So reflection of light in regular surfaces and the reflection of light in irregular surfaces. We'll see. Can we see our image on this object, on this hand? No, we cannot see the image on the hand. Why? Why? Because it is irregular shape. It is having the irregular shape, right? So let us take a mirror, right? A mirror. Can we see the image on the mirror? Yes, of course we can see. Why? Why? Because it is a plane surface, right? So in plane surfaces, what happens? Let us take plane surface. Plane surface. Right? So in plane surface, what happens when the incident ray is incidenting at this direction, and after reflecting, it will move like this. Right? So when a light ray is coming in this direction, then it will move like this. Right? So then what happens? The gap between these two rays will be equals to the gap between these two rays. So these two are incident rays, right? These are incident rays and these are reflected rays. So the gap between these two rays will be equals to the gap between the incident rays to be equals to the gap between the reflected rays. So here what happens? These are coming parallelly and hitting this surface. Okay, and let us take irregular surface. Okay, so when a light ray is incidenting here, okay, so then what happens? This will move like this, and another ray is parallel to this incident ray and hitting here. So then what happens? This will move like this. A light ray is coming like this. Okay, and after reflecting, it will move like this. So then what happened here? What happened here? Here, the reflected ray is change its position, right? So for that reason, we are unable to see our face on the hand. Okay. Next, we will see the loss of reflection. So you have already discussed in lower classes the laws of reflection. What are they? They are when when the incident ray, reflected ray, and the normal. So first we'll see the definitions of the incident and normal and reflected rays. So the first one is incident ray. So what is incident ray? What is incident ray? Let us take a mirror here. Okay. A mirror is represented by like this. Okay. So when a light ray is incidenting on this mirror, then this object get reflect, right? Right. So this, sorry. So this ray is called incident ray. Incident ray. And this ray is called reflected ray. Reflected ray. And we have to take a normal. So from where do we have to take the normal? Normal is always perpendicular to the surface, right? So this is my surface, right? Right. So the normal to be taken from this surface, that means this, a perpendicular line, and this is imaginary line. So this is our normal. Normal is always to be taken from the perpendicular to the surface. Okay, so this is our normal, and this is my incident ray, and this is my reflected ray. Right. So the angle of incidence and the angle of reflection we are going to see. So when here what happens? This light is coming from this direction, right? So this is called incident ray. So the angle between incident ray and the normal is called angle of incidence. So this is my angle of incidence. And next we'll see the angle of reflection. What is the angle of reflection? The angle of reflection is that the angle between the reflected ray and the normal. So let us take this is our reflected ray angle. So angle of reflection is this, right? So here coming to the loss of reflection. Loss of reflection. So we have already discussed in lower classes. So FIECT reflection. So what are the laws of reflection? First law will be equals to the incident ray, normal and reflected ray lies in the same plane. So incident ray, reflected ray and normal lies in same plane. Lies in same plane. So what is the meaning of same plane? Same plane means what? So let us take a mirror here. I would like to take. Okay. So the perpendicular line, that is normal, I would like to take from here. So when a light ray is coming from this direction and is moving in this direction, right? So this incident ray and this reflected ray and this normal to be in the same plane. So let us take. So I would like to take it from here. So incident ray is coming. So I am considering this as my mirror. Okay. So the incident ray is coming from this direction and hitting here, and after this it will move from this direction. So then what happened? Here it is coming in this direction and it is moving in this direction, and normal is along with this the surface. So then what happened? Here. These three are in the same plane, right? So it is coming like this. It is coming this direction and it is not moving in this direction, right? So then what happens? This will comes here and it will move here, right? So this reflected ray and this incident ray and this normal, three are to be in the same plane, right? And next, angle of incidence is equals to angle of reflection. So here what happens? This angle, the angle of incidence is equals to the angle of reflection in the laws of reflection we have seen, right? So let us take the glancing angle. What is glancing angle? What is glancing angle? The angle between the incident ray and the surface. So here what happens? Here we have taken this incident ray and this is reflected ray, right? So this is angle of incidence and this is angle of reflection, right? So the angle between incident ray and the plane is to be taken as glancing angle, right? It may take this also, the angle between reflected ray and the surface is also be taken as the glancing angle. Why? Why? Because this glancing angle here we have to take here the angle of incidence is equals to angle of reflection, right? So for that reason, so how much the angle to be there from here to here will be equals to the same from here, right? So for that reason we can say this angle and this angle both are to be taken equal in reflection. We have to mention in reflection, right? Next, coming to the deviation. What do you know about the deviation? So deviation is nothing but the angle, the original, the extended incident ray. Okay, let us take a mirror here. Okay, here we are taking a mirror, right? And we are taking a perpendicular line. That means this is the normal, right? So this is my incident ray. This is my incident ray. If we are going to extend this incident ray, it will move like this, right? Right? So it should be in this direction, right? So then what happened after getting a reflect, it went to this direction, right? So here what happened, this is my angle of incidence and this is my angle of reflection. This is my incident ray and this is my reflected ray. So here what happened, this incident ray is deviated, right? Deviated from here to here, right? It went to here. So this is my angle of deviation. This is my angle of deviation. Angle of deviation is represented by delta. Okay, so this is my angle of deviation. We are going to use this so many times in next session, right? Okay. So here we have discussed about the everything, loss of incident ray. We have discussed about the incident ray, normal, reflected ray, and the loss of reflection, and the glancing angle, and the deviation we have discussed. Right? Now we are going to discuss about the what is the real image, what is the real object, what is the real virtual image, what is the virtual object. We are going to discuss now. Okay. So I would like to erase this. So first thing, what do you know? What do you know about the real? Real means what? Real means what? Okay. What is the meaning of virtual? Can anybody tell? Okay. What is the meaning of virtual and what is the meaning of real? So real. So first we'll write the real object. Real object. What is a real object? So let us take an object here. Let us take an object here and we keep a mirror here. Okay. So here the perpendicular line I would like to take from here, right? Okay. So here this object is my real object. It is really exist, right? So for the reason we can call this is a real object. Okay. So here after getting the reflect. Right? After getting reflection, it will move to here, right? So this is my virtual image. This is my virtual image. The object which is behind the mirror, then we can call that is the virtual image. So here, let's take like this. So these are incident rays, right? So these are extended like this, right? Right. So here what happens? This incident ray is coming and falling here, and after falling it, they are to be taken as incidenting here. So we can call this is virtual image and this is my real object. Okay. Next we will see real object and virtual image. Virtual image. Right. So here we will see one. So here if we take the object here, right? So the distance from here to here is, let us consider u. Okay. So what is the distance from image to the object, image to the mirror? That is also equals to u. Why? Why? Because let us see here by taking the triangle, equilateral, not equilateral triangle, by taking the properties of triangle, right? So see here you see let us consider this is x. If we consider x and this is y, okay. So see the The same triangle here we are going to get, right? So this angle and this angle are the 90 degrees, and the how much angle to be there from here to be, sorry, here. The angle from here will be equals to angle from here. So then what happens? The length of this object will be equals to the length of the image. The image distance is equals to the object distance. So image distance is equals to object. Let us write clearly. So image distance is equals to object distance. Right? Okay. Next, coming to the, so where do we see real objects and virtual images? So in daily life, we are going to see our face, our beautiful face inside of the mirror, right? So our beautiful face is our object, and the inside of that we are going to see the image, right? So that is our virtual image. Okay. So virtual images are not caught on the screen. The definition of that virtual image is the image is not going to form on the screen. So let us take here, I would like to take a mirror. Okay, here I kept an object. Okay, I kept an object of light. Let us take a light. Okay, so this light is going to hit here. This light is going to hit here. Okay, after getting hit here, it will move like this, right? So then what happens? This object is going to form here also. So let us take this object is bigger. So this is my object. This is my real object, right? So this is my virtual object. So it's a virtual image. This is my virtual image. And this is my real image. If I keep a screen here, then this object, this light, right? I would like to take light, right? So this light is going to incident on here. So for that reason, we can say that is our real image. Okay. Now let us take the field view. Okay. So here I would like to take. So I would like to keep a mirror here. Okay, so I would like to keep a mirror here. Okay, so I just kept an object here. Okay, my object is here. Okay, so from where we can see this object? So here, if the person is sitting here, can see this object, this image, this person's image. No, will see. So if a person is here, can this person see the image of this person? Will see. Okay, so how do we take the field view? Let us write the field view. Right? So this object is to be moved to here, and then it will move like this. Right? How? Why? Because angle of incidence is equals to angle of reflection. So the arrow marks are very important here. Okay? And this incident ray is incidenting here. Let us take up to here only. Okay. After reflecting, it will be move like this. Right. So whenever a person is sitting inside of this view, the person can able to see this object image. Okay. So then a person is sitting here, right? So then he can see the image of this particular person. If the person is sitting here, then he cannot see the image of this particular person. Those are called field view, right? Field view means what? The field where a person can able to see the image of another person, right? So the image is going to form of this person will be here up to here. Right here, we are going to get the virtual image of this particular person.